Hello, my name is Kevin Clay, and I am one of the Lean Six Sigma instructors here at Six Sigma Development Solutions Incorporated. Today, I am going to give you a brief introduction to the statistical test called correlation and regression using Minitab version 20. Correlation and regression is a statistical hypotheses test. Correlation and regression actually can fit a number of different tools. We are going to specifically focus on simple linear regression. Simple linear regression is basically looking at two continuous data sets, all right, both in my X and my Y. And it is seeing or telling us whether there is a statistically significant relationship between the two. And it's giving us the outcome in a p-value. So you're looking at data here on my screen, and you'll see that there's a column called daily defects in humidity at DC Site 1. Okay, this data comes from a fictitious project that we use as a benchmark with our green belts and our black belts. It is following a fictitious company called Peanut Butter and Jelly Inc., PBJ Inc. And they have initiated a Lean Six Sigma project to understand why their costs have gone up in the construction of a peanut butter and jelly sandwich. So this company provides PBJs to schools all over the domestic US. And again, their cost per sandwich is rising past what they believe their cost should be. So their margin is shrinking. We're in the analysis phase. In this case, we're looking at correlation and regression, and we're looking at seeing if there is a relationship between the amount of daily defects and the humidity at DC Site 1. So we have this hypothesis that there is some relationship between that humidity and the amount of defects created. All right. But again, we're not going to make the judgment that exists. We're going to let a statistical tool tell us. So we are going to use the assistant in Minitab's version 20. The assistant makes it really easy to do a statistical analysis. It makes it a lot more simple to put in the information and also get a result. Okay, so we are going to go into simple regression rather than multiple regression. We are going to choose simple regression because we are only comparing one X, all right, to one Y. So our Y in this case is daily defects. Okay, our X is humidity at DC Site 1. And we are going to let Minitab choose for us whether this regression, if there is one, is a linear regression or a quadratic regression. So it's that's why I love the assistant so much, especially for green belts, because this in the old way, I won't call it the old way, but there's another way of doing this, but it's more manual. And you have to really kind of vet whether different types of regression, which one fits that regression model the best. In this case, Minitab does it all for you. So it makes it a lot easier. We are going to have an alpha level 0.05 that's correlated directly with our confidence level or interval, all right, which is 95%. We can change that, but we're not going to do that in this case. If you want to know more about that alpha level, and the confidence level or a confidence interval. You can go out and do a Google search, go to minitab.com. They've got great articles to really help you understand what those mean. Okay, we'll hit OK. And this will come up with a number of good graphs, very informative graphs. We'll go all the way down to the bottom. Okay, we'll click on the report card. So you have to double click in order to bring that forward. The report card just tells us both just information about our data, our model, and it also tells us whether we have good data, whether we have the proper data to be able to trust the model. Okay, so it says our sample's large enough, just giving us information. Unusual data, it says that we may have some large residuals. All right, 3 data points have large residuals and are not well fit by the equation. So I'll show you that here in a minute. And to us, we teach our green belts that those are signals. We like to stop and go out and say, what caused those? Because there's a potential, and I've seen in many projects, that those signals could lead us to the answer to the problem that we're trying to solve in our Lean Six Sigma project. Okay, because we have at least 15 data points, then we potentially could determine whether or not it's normal or not. Now I say potentially because Minitab doesn't know whether you have taken a good random sample. All right, whether you have included the variation from all the different X's. Okay, you could be taking data from, or you could be doing a project on 3 shifts of a manufacturing plant, but if you only take data on the first shift, then you have actually skewed your data and biased the outcome. So Minitab doesn't know that. Minitab just knows that you put data in, and it says because you have at least 15 points, normality is not an issue. Again, as long as we've taken the right amount and a random representative sample. Okay, so we'll move on to the next graph. The next graph, we'll skip this. This is just the prediction reports. It is valuable, but I'm going to stick to those things that are really kind of easy to digest. Okay, then we come up to the diagnostic report, and this is where, when you see these red dots, these are those unusual values. All right, and so this is pointing to maybe something specific is happening. You can hover over these, and it will tell you, what row that comes from. So you can go back and basically look at the data to see why it would have such unusual fits or residuals. Okay, we come up to our model selection report. And this really just talks about the model that was selected. So this was a fitted line plot. All right, so this was a linear, it fit a linear model. And again, you see your large residuals, your unusual X's. So, quite a few of these that we might need to go out and investigate. We come up to our summary report. Our summary report up in the upper left-hand corner, is there a relationship between Y and X? And with a p-value of 0.001 and a confidence level or interval of 95%, this is saying that yes, there is a difference, right? So that there is an effect. Now, You can't necessarily take that as law, because now we need to go down to our R squared. And our R squared, this is basically telling you, and here's a good script, that 11.50% of the variation in daily defects can be explained by the regression model. Now, there's only one other variable in our model, all right? And that's humidity at DC site 1. So it's basically saying 11.50 of the variation in daily defects can be explained by humidity at DC site 1. Okay, now that leaves like 88.5%. I think my math was correct there. Leaves that much unexplained. Either it's in your data somewhere, and really there we only have one X. But if we had multiple X's, and we only looked at a simple linear regression, it could be saying that, hey, there might be something in these other X's. And unexplained could be the fact that we haven't taken data on a variable that we have not explained yet. All right, so humidity could be one. It could be something else like, let's say, humidity causing defects. It could be shifts causing defects. All right, so there could be, other things that could explain that. That's what that means by unexplained. Okay, and then down here it says the correlation between X and Y, and this is based on what's called the correlation line. All right, it's looking at the Pearson correlation coefficient. Okay, I'm not going to get that much into that. Again, I want to make this a little easier to understand. So. From a practitioner standpoint, we would look at this and say, okay, we do have a relationship, but the strength of that relationship is not really that strong. Now, if we know there are a lot of unexplained variables out there, and we're going to get to those, this might just tell us right off the bat, hey, there could be something in DC or in humidity at site DC. I'm sorry, let me say that again. The humidity DC site 1. And that might lead us to going back and saying, okay, what other X's can we define to raise that number? And then we can do a multiple regression. Okay, so I hope that this has given you a little bit more information about the simple linear regression that we use in the Minitab's version 20's assistant. Again, my name is Kevin Clay, and I am one of the Lean Six Sigma instructors here at Six Sigma Development Solutions. If you have any questions, please do not hesitate to contact me. My email is kclay@sixsigmadsi.com. I will put that down in the details below the YouTube video. And I hope everybody has a wonderful day.